Well, hello, anatomy students. Mrs. Shelton here, talking to you about our next unit. So this is our second to the last unit during distance learning. So this is going to be chapter 12 on the blood and also chapter 13 on your cardiovascular system. So for chapter 12 and 13 combined, we are combining them. We'll have 2 weeks to work on this. We will have an activities guide, and so this is going to lead you through some interactive activities. And then also we have, like always, we've got our reading guide. We changed the format of it though to make it easier for you to digitally answer instead of handwrite, and be able to upload this. So we have these text boxes for you with the questions and the answers. But this reading guide is the exact same questions that we posed on the old reading guide. The key is posted on Schoology. It's just a slightly different format for you for this particular unit since we're now in distance learning. So this one includes chapter 12 on blood, just the first two sections, and then chapter 13 on your cardiovascular system, and then also then the review questions are at the very end. So in 2 weeks, you'll be submitting your reading guide, review questions, and then also your activity guide. Now, to help you in understanding the reading guide and the contents that we're expecting you to know, I am going to walk you through the first PowerPoint. So this will be your first lesson, which is just looking at the first two sections of chapter 12. So this way you get a good overview of your blood and the components of blood that we're asking you. So that's what this Screencastify is going to focus on. The next Screencastify will focus on your heart and blood flow through the heart. And then your last Screencastify will be talking more about disorders and treatments and making sure we understand for heart why it's so important to make sure that we have good heart health. So for chapter 12, let's go ahead and get this going. So for chapter 12, again, we're not covering the entire chapter, just section 1 and section 2. So just focus on those when you're looking at your textbook in order to answer the questions off of your reading guide. Now, with your blood, you should know that we have in our body, depending on your size, you have anywhere from 4 to 6 liters of blood inside your body. Your blood, really what it consists of is 45% of your blood is actually red blood cells for transporting oxygen. The other 55% is plasma. Plasma is going to be water, it's going to be salt, it's going to be hormones. And then we also have this small layer here that is your white blood cells for your immune system, and then also platelets that are for blood clotting. So here's just a diagram to help you see some of the cellular components that we'd expect to find in your blood. Now, this is not how your blood naturally separates. You would actually just see your blood all in one solution. However, this has been centrifuged in order to be able to see the percentage composition. This is also referred to as a hematocrit. So you're going to see that on your paper as well, in order to just get a good idea of that red blood cell count that's there, because oxygen carrying capacity is just so vital for us to be able, all of our cells to be able to do cellular respiration. Now, with your blood, here's actually a really good diagram to help you explain all the different components of your blood. So like I said, about 45% of your blood is red blood cells. So, but of that, then we've got our white blood cells. So your red blood cells, all they are for is for transporting oxygen. That is their sole purpose. We have cell fragments. These cell fragments are called platelets, and these cell fragments are going to be involved in the blood clotting process. So if we rupture any blood vessels, and then white blood cells, which of white blood cells, there's 5 different types of white blood cells here. These white blood cells are going to be for your immune response. And so these, if you actually had an infection, your amount of white blood cells would actually increase in order to be able to fight that particular infection. Now, when we do talk about red blood cells, we refer to these as our erythrocytes. That's their official name, is erythrocytes. You will see on my answer key that I write red blood cells as RBCs. It's just shorthand notation, so it's just easier to write RBCs instead of red blood cells all the time, or erythrocytes. So do make sure that you know that name. Now, when we talk about white blood cells, collectively, white blood cells are referred to as leukocytes. So with leukocytes, all of these different types in here, so neutrophils, eosinophils, basophils, monocytes, lymphocytes, they're all classified then as leukocytes, is what those would be. Now, these again are your cellular components of your blood. Now, in your blood, about 55% is then considered plasma. This is kind of looks like a yellowy solution if you've ever seen plasma. Now, what that mostly is water. So with that, that's water. About 92% is water. 92% of your plasma is water. But then also in there too, we're going to have electrolytes. So electrolytes is just ions, ionic particles. So your sodium, your potassium, chloride ions. Those would be your electrolytes, different proteins, fibrinogen, which is an important part of um, the blood clotting process. We're going to have antibodies, amino acids that are going to be going to different parts of your body for protein synthesis. Waste products are going to be in your plasma. All of our nutrients that we consume, all the vitamins, all the hormones for long distance signaling, all the sugars. So this is where our blood sugar would be taken. And then our gases are also going to be dissolved in the blood or carried on the red blood cells. So oxygen gets carried on the red blood cells, carbon dioxide, and then nitrogen gas, that's going to be dissolved then in the plasma. Here is your erythrocyte, just looking a little bit closer at just its basic structure. Now, an erythrocyte is a cell that's going to last in your body up to about 120 days from the time that it was produced. It's produced in your bone marrow, like you already know, but really what a red blood cell is plasma membrane that is just packed with a protein called hemoglobin. It has one job and one job only, and its sole job is to transport oxygen. It is not a cell that is ever going to divide. This cell has no nucleus, it has no organelles. Through its creation, it did actually, in different stages, have a nucleus, have organelles for producing massive amounts of hemoglobin. But really, by the time it gets released into your blood, it is just plasma membrane with hemoglobin in there in order to transport oxygen. And again, after about 120 days, it's going to be broken down by your liver and out it's going to go into your toilet, is what's going to happen. And we are constantly making more red blood cells in order to make sure we maintain about that 45% of your blood being red blood cells. Here's an electron microscope picture of your red blood cells. So it does have this concave. It looks like somebody has just taken a jelly-filled donut and forgot to fill the jelly, and it kind of squished down in the middle. So when you do see it under a microscope, it looks a little lighter in color in the middle, and it's going to look darker just because of the density of the hemoglobin that's there. So when we also, again, here's another diagram just showing our red blood cell. Remember, it's just packaged hemoglobin. This protein hemoglobin, its job is to carry oxygen. And so they're just showing you that a single hemoglobin molecule can transport 4 oxygen molecules at a time. We've talked about anemia. When somebody refers to themselves as having anemia, there's all different types of anemia. But what we mean by somebody having anemia is for some way, shape, or form, they have a decreased ability to transport oxygen in their body. So oftentimes, some people are anemic because they don't have enough red blood cells, and that's what we're seeing here in this particular picture. Other types of anemia, the most common type of anemia is iron deficiency anemia, and what you would see there is these red blood cells. There are numerous, so there's the correct number of them, but each red blood cell is only partially filled with hemoglobin because there just wasn't enough iron in order to be able to make that protein hemoglobin. Now, in making red blood cells, there's actually a hormone that is released in your body when your red blood cell count is low. So if you are somebody who's ever donated blood, so if you went and you donated a pint of blood, what is going to happen is your kidneys and your liver are going to actually sense and recognize that your red blood cell count is low. So what is actually going to happen is they're going to secrete a hormone called erythropoietin, also known as EPO, and the target cells for EPO are your bone marrow. And so your red marrow in this spongy bone in your bones is now going to increase its red blood cell production. And so you're going to increase number of red blood cells until you have an adequate amount. And then your liver and your kidneys are actually going to stop then making EPO when you hit that set point. So there's a negative feedback system to always make sure that you have plenty of red blood cells. Now here is just a microscope slide, just so you can see what a microscope slide might look like of your blood. and we can see just lots and lots of red blood cells. This would be a white blood cell. This is a right stain. In order to be able to see the white blood cells a little bit more clearly, there's a stain that actually stains these kind of orangish and purplish colors, so all 5 of these. So this is one type of white blood cell that you don't need to be able to identify what type it is. You can wait till college anatomy class in order to do that. But you can also see these little platelets. So these little fragments that are in here too, those would be the platelets. But then we're seeing the red blood cells kind of spread out so we can see them. Now, in this particular picture, we're actually seeing a different type of anemia, which is sickle cell anemia. And with sickle cell anemia, somebody who has sickle cell anemia, this is a autosomal recessive genetic trait. And so with this, in times where their oxygen levels are low or their blood becomes more acidic, what ends up happening is the hemoglobin turns into this sickle shape. It actually starts kind of clumping together and makes the red blood cell now move into this sickle shape. Here is baby tanning booths, not baby tanning booths. So one of the things we do need to make sure we understand is that since our red blood cells are in constant production and they're constantly breaking down, it is the role of your liver. So one of the many roles that your liver has, your liver is actually needing to break down that hemoglobin and turn it into bile that can now be released through your digestive system. Well, when babies are first born, their type of hemoglobin that was in the womb actually has to make a very rapid change to hemoglobin for breathing in the air. And so some babies, that turnover actually slows down and the liver can't keep up with converting all of that hemoglobin into the bile. So it ends up being this protein, this intermediate protein called bilirubin that starts building up in the skin. Well, what we have determined, and this is very common in babies, to kind of have this yellowing of the skin and the eyes. And it's just in order to help them out, UV light actually helps break up that bilirubin and get that converted. Now, if you at your age start developing a yellowing of the skin and start feeling fatigued, get to the doctor right away because now jaundice, this yellowing of the skin due to a buildup of bilirubin, is not normal in adults. It is not a normal thing, and it's an indication that you have some type of liver disease or liver failure. Now, in this diagram is going to help you out just a little bit more in helping to understand this bilirubin that would build up for somebody in jaundice. So here's my liver that's here, and in this breakdown of hemoglobin, well, here we just know that in this breakdown of hemoglobin, here is this substance called bilirubin that is actually supposed to get converted to bile and then get released through the intestines. So when this doesn't happen correctly and the liver can't keep up with this conversion of it into bile, this bilirubin can start building up in the skin and that yellowing. But what this is also showing you are some of the components that are necessary. So from my diet, I'm going to need B12 and folic acid, and I'm going to need iron. These are 3 important vitamins and minerals that are necessary in my diet in order to be able to make red blood cells correctly. So if you are anemic and iron deficient anemic, well, we need more iron in your diet. You're going to get more iron in your diet, a lot of different sources. I've already told you spinach. Spinach is an awesome, awesome thing to just blend up in a smoothie every morning and get your iron that way. B12, folic acid. We're going to get B12 and folic acid from some of our grains and some of our nuts, but really just kind of making sure that you're eating a well-balanced diet. Some people add in red meat as a source. Other vegetarians are going to be eating more of your dark green leafy vegetables and some of your very colorful types of fruits, vegetables, and beans and nuts is what's going to give you B12, folic acid, and iron. So now your bone marrow can make red blood cells in an appropriate amount and in an appropriate content of hemoglobin for oxygen carrying capacity. Now, in your bone marrow, you have stem cells, and these are what are referred to as pluripotent stem cells. And so, depending on what signal hormone they receive, those stem cells will actually break into cells that and differentiate into cells that produce red blood cells, or a type of cell that's going to break down into platelets, or these different cells that can now actually make our different leukocytes, our different white blood cells. And so they're all stemming and they're all produced and originate in your bone marrow, just so you know, from these pluripotent stem cells. But it really is a matter of which signal molecule do they receive in order to then become your erythrocytes, your platelets, or your leukocytes. Now, another concept that we need to be addressing is we need to address what our blood type is. And when somebody says that I am, and I'll just use me as an example, I am O positive blood. Well, what I'm telling you is I am telling you on my red blood cell. So remember I told you your red blood cells. It is plasma membrane filled with hemoglobin. Well, plasma membranes actually have on them, they have protein markers called antigens. And these protein markers are actually used for organisms to be able to communicate from cell to cell. And it's also a way for our immune system to determine which antigens are belonging in our body versus which antigens are foreign and we need to attack. So for me, I being O positive, my red blood cells would actually just have this Rh antigen on it and would not have the A or the B antigen on it. Now, in somebody had all three of these antigens, this would be somebody who would be considered AB positive, would be their blood type. So what I'm telling you when I tell you my blood types, I'm telling you what A and B antigens do I have, and do I have an Rh antigen or not? There's actually two sets of genes that determine our blood type. So there's the ABO blood group that determines whether or not you're A, you're B, you're O, you're AB. Or there's the Rh gene that's going to determine whether or not you have the Rh antigen or not as well. Now, as far as blood type is concerned, I am super normal and common. Being O positive, this is the most common type of blood in the United States. The least common is actually AB negative, where about 1% of the American population is AB negative. So that would mean that they have the A antigen, they have the B antigen, but they do not have the Rh antigen. If you're AB positive, because actually having the Rh is pretty common, it's the dominant allele. This would be the recessive allele, so it is less common. So with that, we actually see that there's more people who are positive. They have that Rh factor, that Rh antigen, versus the other. But since so many people, now O is actually negative, you guys are going to do on your activities, you're going to do some genetics problems. O being recessive, if I am O positive, or if we just simplify it, if I'm type O blood, if my daughter's father is type O blood, then I don't even need to blood test my daughters because their only thing they could be is also type O blood. But you guys are going to do some genetics problems and just kind of determine how genetically our blood type is determined. Now, you are also going to be doing an activity that is going to be for blood typing. Now, for blood typing, when we have an unknown blood, we actually are going to see how it reacts with antibodies that act against those antigens. And so since there are three antigens, there's the A antigen, there's the B antigen, and the Rh antigen. Well, now if I mix blood with those antibodies, so antibodies will attach to red blood cells. Antibodies are what your immune system produces in order to attack foreign antigens. So in this particular case, I took 3 drops of one type of blood. I mixed it with A antibodies and it started clumping. That's evidence that this blood actually has A antigens on it. The B antibodies didn't react. So that tells me that there were no B antigens on that red blood cell. And then here, the Rh antibodies made it clump. So this tells me there is the Rh factor. So I look for this clumping response when I take unknown blood and I mix it with my 3 known types of antibodies. And so that's what you're going to do in the blood typing game. You guys are going to do blood types for different patients, and you're going to then actually try to give them blood transfusions without killing them. It's actually kind of fun to watch, see what happens. It's an animation, and they scream if you give them the wrong blood type. Now, here's just another diagram that just helps you understand the antigens, these proteins that are already existing on the surface of our cells. And this is just the ABO system, but it also tells you what antibodies your immune system would be producing. So, like for me, I'm type O blood. Well, since I don't have the A or the B antigens on it, my immune system actually makes antibodies that will fight off A or B. So, as a type O person, I can only receive blood from type O people. If I receive blood from any of these other types here with A or B antigens on it, my antibodies are going to clump up that blood, agglutinate it, and that's going to cause clotting throughout my organs and possibly cause me to die. So again, here's just this process. This is going to be the similar blood typing that you guys are going to do on the blood typing test, where you're mixing with known antibodies to see if you get this agglutination or this clumping that happens. Now again, the Rh system, it's just a different antigen that is determined by a different genetic system. So when we say positive, that means that there are Rh proteins or antigens that are on the surface of those red blood cells. And if we say somebody's Rh negative, that means they don't have those. So this is also why the universal donor for blood, the type of blood that is stealth-like, that immune systems can't even detect, is actually O negative blood. If you have O negative blood, you will be in high demand for donating your blood because you are considered a universal donor. Now, when it does come to Rh, something that females need to be concerned with, if they are Rh negative, this means that your body makes antibodies against Rh positive. Now, those antibodies happen to be small enough that they can actually pass through the placenta. So they do have a risk if you are not under a doctor's care, if you have a baby who has positive blood. Now, the blood from mom and baby don't mix. The placenta is actually designed to exchange nutrients and oxygen with the baby. However, because these Rh antibodies are so small, they can actually pass through to the baby, and those antibodies could start agglutinating that baby's blood. So it's very important that you are under doctor's care. They give you a medication that inactivates those antibodies during your pregnancy, and then the baby is healthy and just fine. Now, here's a diagram that's going to help you with your reading guide. This is just now talking a little bit more about your types of white blood cells. So your types of leukocytes and what they do, you do not need to know that for the test, but you should be familiar with your two different types of lymphocytes. Your B cells and your T cells is what you have already heard them referred to. Your B cells actually mature in the bone marrow. So all of these cells are produced originally in the bone marrow. B cells, the B stands for bone marrow. They mature in the bone marrow, and these are your cells that produce antibodies. And these cells, once your B cells have learned how to make a specific antibody, they remain in your body as memory cells, hopefully for the rest of your life. Now, T cells actually first get produced in the bone marrow, but they mature up in a gland called the thymus. And so that actually gives them a different specialty. And there's several different types of T cells then, we don't need to get into that. But these T cells then are going to directly attack infected cells and also engage in other just direct cell-to-cell communication is what a T lymphocyte is going to be doing. And we also develop memory cells then too. So when we say somebody is immune to an infection, it's because they now have these memory B cells and these memory T cells that are in their system. Here again, just another diagram that just is going to help you go through the different cells and make sure that you're understanding red blood cells, so your erythrocytes versus leukocytes versus platelets. Now, when you hear the word leukocyte, you should probably think, oh, I think I've heard of leukemia. So with leukemia, what is happening if somebody has leukemia is in the bone marrow, what is happening is the cells are producing way too many white blood cells. Now, that does not mean that they have superhuman immune system and they can withstand everything. When that is happening, those cells, these white blood cells are being produced in such high numbers, they're not functioning normally as white blood cells that are going to be for your immunity, and you also have a decreased amount of red blood cells too. So somebody who has leukemia, oftentimes what they start feeling is just fatigue and tired and getting sick a lot and run down a lot. And that's when, just through a simple blood test, they can actually draw blood and just kind of now go, oh boy, we need to admit you and figure out exactly what this type of cancer is. Each of our white blood cells, it's actually easy to count which white blood cells, and this will be something you do in a college anatomy class, not in a high school anatomy class. Based on the staining and the pattern, you can actually identify which white blood cell it is. And there are certain percentages that are normal in our body, but they all have a different appearance, a different staining, different granulation that's in them that helps us determine exactly which white blood cell we are looking at. And again, that will be something that you do in a college lab where you are really just tired of staring down through a microscope and drawing white blood cells. Now, our white blood cells travel through our body mainly through your blood vessels. Now, there are some that travel through your lymphatic vessels too, but when you have an infection, we've talked about the importance of inflammation. And so when you do have a localized infection, well, what ends up happening is there is a histamine response that increases the permeability of these capillaries. Now, to increase the permeability, that's going to increase the amount of fluid that comes out, but more importantly, it now allows for these white blood cells to be able to escape from your blood vessels and now get to that surrounding tissue where they can actually fight off that bacteria or that virus that is in that area. This particular diagram is helping you understand the clotting process. So when we rupture a blood vessel, which happens all the time, and you get a bruise is internal bleeding. You have ruptured capillaries that actually need to be stop the bleeding, we need to clot it. And so with this particular process, it is platelets that are going to be starting the process. They're kind of sticky and they're going to stick to these tears and capillaries or these breaks in blood vessels. And that is actually now going to start now a protein cascade reaction, a positive feedback reaction that ends up converting this protein that was called this fibrin-fibrinogen conversion is actually going to create this cluster of red blood cells and fiber that's going to plug the hole temporarily until you can build more capillary walls. Here's some more antibody reactions. Now, this particular picture here, and this is something we'll talk about with the heart, is we will talk about heart disease, and one of the key elements or the key risks of heart disease is one, hypertension, but the amount of cholesterol, and then how much buildup of plaque, so how much atherosclerosis buildup has occurred in some vital arteries. And so what we're seeing here is a normal, healthy artery. But in here, this artery is so stretched out, and it's the walls of the artery that have now been packed full of this plaque that is the disease atherosclerosis. Now, this is an incredibly severe case of atherosclerosis, and we're also not knowing exactly which artery this is, but most likely it was probably the coronary artery, because that is the most common type of atherosclerosis heart disease is coronary artery disease. This diagram here, in case you're interested, this is actually going to show you kind of the cascade effect of this transition from these proteins that exist and how we actually start getting blood clot formation. It's not just a one-step process. We actually have this protein called prothrombin that has to get converted to thrombin, and then that thrombin can convert this fibrinogen that also exists into fibrin to now actually start creating this clot, because we don't want blood clotting to just happen randomly. And that's one of the issues that happens with atherosclerosis is atherosclerosis could trigger a clotting process that happens in some of your vital arteries that fuel the heart. And that's going to lead to a heart attack when you start getting these clots that now build up in some of these vital lines. So what you're going to see on just some of the next slides, when you go back to the PowerPoint, there's some additional slides that are just here for support to help you with blood typing, some other diagrams along those lines. But for the main things that we have discussed, covered what Chapter 12 really, the information you should be getting out of Chapter 12, and just making sure that you understand the importance of blood, you're understanding anemia, you're recognizing that if you are fatigued and you're tired, but you're eating right, really the first thing to do is to make sure that you are checking your diet and making sure that you are not anemic in some way, shape, or form, and that your blood is carrying oxygen levels normally. And if you are constantly getting sick, we need to make sure that we are checking your white blood cell count in order to make sure that your immune system is also responding normally too. So, with that, let me just get down to the end here, and I'll be in touch as always. Shoot me an email at any point in time because I'm here to help you, even though we're distance learning. But we will talk soon.